So number 2 is all about adding, subtracting integers and decimals, as well as using order of operations. So part A, both numbers are positive, so that is going to produce another positive answer. And so when we add them together, if we stack them up in no particular order, because we're adding, 2 plus 3 is 5, and then 1 plus 1 is 2. So that answer is 25. As for a situation when both of them are opposite signs, so remember that the 12 is an imaginary plus sign, right? So when you have opposite sides, you want to look at it as the bigger number wins in terms of the sign. So since 13 is bigger than 12, and 13 is negative, so that means that the answer is going to be negative overall. And so again, when you do have opposite signs, we're technically subtracting. So 13 minus 12 is technically what we're going to be doing. So 3 minus 2 is 1, and obviously 1 minus 1 is 0. So when we subtract them, we actually get 1. But again, since they are opposite signs, our final answer is actually going to be negative. So for part C, notice it's the other way around. So again, we have opposite signs, and that means that we're technically really subtracting here when you have opposite signs. But again, the sign of the bigger number wins. So in this case, right, again, 13 is bigger than 12. 13 is a positive number. And so our answer is going to be positive 1 in this case. So in this particular case, when you have both of them as a negative, that's going to produce a negative answer. And so when you have the same signs, you're actually technically adding, right? When you have opposite signs, you're technically subtracting. So in this case, right, we're technically adding them together. And when you're adding, it doesn't matter if the bigger number's on top, right? So we already knew from part A that the answer was going to be 25, but because they're both negative, that answer is always going to be a negative. So here we have another situation where we have opposite signs, right? The imaginary sign in front of the 6.5 is positive, and 6.45 is bigger than 1.23. And because the sign of the bigger number wins, we know that our final answer will be positive. And again, as I've been saying before, when you have opposite signs, it's technically subtraction, right? And when we subtract, we like to put the bigger number up top. Notice they're already both to 2 decimal places, so they're already stacked. If that wasn't the case, you would just add a 0. So you know that you're subtracting the correct number. So 5 minus 3 is 2. 4 minus 2 is 2. Make sure that you stack, everything's organized, the decimals, and then 6 minus 1 is 5. And again, we already know, as I said before, that it is going to be a positive answer. So now what happens when you are subtracting a negative? So think about it as when you have 2 minus signs next to each other, they join together and form a positive. So 6.45 minus a negative is the exact same thing as saying 6.45 plus the 1.23, right? These two join together and make a plus sign. And so when you are adding and subtracting decimals, you always want to make sure that the decimal signs are aligned, right? And notice they already both have 2 decimal places, so you want to make sure those are stacked, right? So 5 plus 3 is 8, 4 plus 2 is 6. Notice I'm staying very organized. The decimals should be in line, and 6 plus 1 is 7. So how do I know if the 7.68 is going to be a positive or a negative answer? When you have 2 positives, your answer is always going to be a positive. When you have 2 minuses or 2 negatives, you're going to always have a negative answer. Now we're going to take a look at order of operations. So remember PEMDAS, please excuse my dear Aunt Sally, if you've ever heard of that before. Some teachers, instead of P, might use GEMDAS or GEMDAS instead. G stands for grouping, P stands for parentheses. They're pretty much saying the same thing. I actually like the G because parentheses actually stands for the group of numbers together, but typically we might see them inside the parentheses. Brackets is also considered the parentheses as well, just another fancier way of using parentheses. E stands for exponents, so you do that next, right? So you start from the top and you go in the order going down. The M stands for multiplication, D is for division. So these are a little tricky because people might think you always multiply before dividing. Those two go together. You always do whatever you see first, reading from left to right. And then last but not least, you look at addition or subtraction. Again, in these cases, it's whatever you see first from left to right. So addition doesn't always come before subtracting. It depends, again, what you see first from left to right. So if we take a look, parentheses, we see that first. So you look at them as a group. So first you do -2 plus 3, which is +1. I would strongly suggest when you do these PEMDAS problems that you always copy down the rest that you don't use. So always stay organized and stack them, right? The next is we do exponents. So that is saying 1 squared, that is 1 times 1, which is 1. Notice then I copied everything else down to stay organized. Then -12 divided by 1 is -12. So for part H, there's a little bit more going on. So remember, I'll write PEMDAS here on the side. So we do want to use parentheses or the group first. If you look, there's nothing there, so we don't worry about parentheses. Next, you ask yourself, do you have any exponents? Nope, so we're focused on that. Next is either multiplication or division, either what we see first as we read from left to right. So notice in this particular case, we do see multiplication first. Remember to stay organized. So 6 times 4 is 24. Notice, super important, that then you copy down the rest that you have not touched and you keep on repeating, right? So again, division or multiplication, we still see those in the expression. So we got to finish those up before we add and subtract the last. So we do see the 24 divided by 12 first, which is 2. And then again, very important, we're going to copy down exactly as we see it. So we still do see a division sign. You always do that before adding and subtracting. So I'm going to copy down the 2 because we didn't touch that. Now we're doing a +72 divided by a +8. That is going to be a +9. And then copy down that -9. Last but not least, we have addition and subtraction, whatever you see first from left to right. So 2 plus 9 is going to give me 11. Drop down that -9. And then last but not least, 11 minus 9 is 2. Number 3 pretty much is properties of exponents. So number 1, the correct answer is actually D. And x to the 4th literally means multiplying x, which is the base, how many times the exponent, as you see in this case 4, so you're going to multiply it 4 times. That is a big difference between 4 times x versus x to the 4th. That would be f. So multiplying 4 times x literally translates to adding x 4 times, as opposed to multiplying, that would be the exponent. Number 3, 8 times x to the 5th power, that would be a, right? So 4 times 2 is obviously 8, but what do you do when you are multiplying with the same base? You're going to be adding the exponents. So number 4, that is going to be b. 8 times x to the 6th, that's going to be b. What happens? That's the power rule versus part A. That's the product rule. You add the exponents. The power rule is you raise it to a power of 3. So you're actually going to multiply the exponents. But just be super careful. A very common mistake is people will just multiply the 2 times 3 and they'll say that's 2x to the 6th. But be super careful. The imaginary exponent of the 2 is actually 1. So you are really distributing, quote unquote, the 3. So yes, 3 times 2 is 6, but 3 times 1 is 3. So you're really doing 2 to the 3rd power now, which is 2 times 2 times 2, which is 8. So for number 5, 2 times x, that would be e. So that's the quotient rule. So 4 divided by 2 is 2. So what happens when you have exponents with the same base and you're dividing? You are going to be subtracting the exponents. 3 minus 2 is 1. There's an imaginary 1 there, right? Number 6, 2 times x squared, that is going to be g. So those are what's called like terms when you have the same base and the same exponents. So what happens when you have one of something and you're adding the same something? Now you have 2 of them, right? So when you're adding, you're going to keep the exponents the same, right? When you're multiplying, that's when the exponents are different. So number 7, that correct answer is C. So this is polynomials, which reviews that later. But again, I just talked about the only like terms are the ones with the same exponents. So the only like terms are negative 4x plus 2x. So you're just going to be adding the coefficients. The coefficient simply means the number in front of the variable. So negative 4 plus 2 is negative 2. And again, when you add and subtract, we keep the exact same exponent. So it should stay to the first power. And then you have the 2x squared, which you leave alone. So notice 2x squared minus 2x is the same thing as if you see in number 7, if I have written it this way, negative 2x plus 2x squared, that would be the exact same expression, but just rearranged. So now we get into factoring. This one's using the GCF method. So first things first, when you factor using the GCF method, the GCF always goes on the outside of the parentheses, and then you have to figure out how many boxes goes inside the parentheses. Well, how many terms are there? There's 2 terms, so there's going to be 2 boxes. Now, whether I'm going to separate by a plus or a minus depends on the problem. And in this particular case, the GCF, I could make it negative or positive. I'll go over both. So the GCF is, what do both of those terms have in common? Well, the 18 and the 9 are both divisible by 9. And again, do I want to take out a positive 9 or a negative 9? It doesn't matter. Let's take out a negative 9 first, right? They're both divisible by negative 9. And then they both have at least 3 x's. So I'm going to take out x to the third. So the GCF is pretty much the distributive property, but in reverse. So you're asking yourself, negative 9x to the third times what gives me negative 18x to the fifth? Well, I know a negative times a positive gives me a negative. So negative 9 times positive 2 gives me negative 18. And then remember, this is the power rule. X to the third times what gives me x to the fifth? And the power rule says that we need to add exponents, right? So 3 plus 2 would give me 5. So then negative 9x to the third times what gives me negative 9x to the third? Well, a negative times a positive gives me a negative, so I know this is going to be plus, and anything times 1 is itself. So this is actually the full entire answer, is all of this. Now, the other way you could have looked at it as, what if you took out a positive 9x to the third? Then the 2 guides inside, right? Those are just going to have the opposite sign. So another way you could have also written it is this way also works. They are both correct. All right, part B, we have 2 things going on. We have the GCF method, and then after that, we're going to use difference of perfect squares. So some people right about now might think, oh, that's difference of perfect squares because it's 2 terms and there's subtractions, right? And then they might realize, oh, 25 and 100, those are both perfect squares. Perfect squares means that when you take the square root, it ends up being a whole number, right? So the square root of 25 is 5, and the square root of 100 is 10. The mistake that people are making is that in order for the variable to be a perfect squares, it has to have an even exponent, right? So we have an odd number there, and then this is to the first power that is also an odd number. So unfortunately, x to the third and x, those are not perfect squares. So the very first thing you should be always looking for anyway, before doing any method, is always looking out if they have a greatest common factor. So what do they have in common? Well, they're both divisible by 25. And also, they both have at least one x. So the GCF is 25x. And again, I said before, when you factor using the GCF method, it's always going to go on the outside of the parentheses. How many boxes do you have inside? It depends on how many terms you have. So we have 2. And then in this particular case, I'm going to put a minus sign between them, but I'll talk about that later. Right, so the GCF is 25x, as we talked about, and the GCF method is the distributive property in reverse. So 25x times what gives me 25x to the third? Well, we already have a 25. We have 1x and we need 2 more, right? The product rule says that the exponents should add up to 3, right? This is to the first power. And then 25x times what gives me that negative 100x. Well, a positive times a negative gives me a negative, so I'm going to need a minus there. And then 25 times 4 would give me 100. Now, should I add an x there? No, because we already have an x. We don't need another one. So that would just be 25x times x squared minus 4. Now we have to figure out, is this factorable? So pretend this 25x here is gone. It's not there. We have to figure out if that's factorable. Now, I don't know if you've ever been taught this, but you're always done factoring when it's to the first power. That's how you know you're done. So if you have an exponent that's bigger than 1, it could be factorable. Maybe it's not, maybe it is, but it could be. So we have to see, is that factorable? And this ends up being a difference of perfect squares. So the template, as you can see, I'm not sure if you can see with my face in the way, so I'll move that up. So the template is, right, if you have a difference of 2 squares, you're going to have 2 parentheses, the same exact expression, except one is plus and one is minus. Now, how do you identify what is A and B? So first things first, let me set up that template. One is plus and one is minus. So in the first spot goes the square root of the first term. So the square root of x squared is x, right? X times itself is x squared. The second spot would be the square root of the second term. So the square root of 4 is 2. And that is it. Now remember that 25x that I crossed out. Let me erase that. Super important, people always forget to put that back. So you should then drop down the 25x, and this is the entire answer. Now, could you do x plus 2, x minus 2, or x minus 2, x plus 2? Absolutely, because of the commutative property. All right, so we have 4 terms. Whenever you have 4 terms, you always want to think factor by grouping. Now, actually, let me back up a little bit. As I said earlier, the very first thing you should look for is GCF, always number 1. So in all of the 4 terms, is there something that all of them have in common? The answer is no. Okay, so that should be your first step. So there's no GCF. The next thing, the next bell that should go off in your head is, how many terms is it? So whenever you have 4 terms, it's always factoring by grouping. It's called by grouping because you're going to group the first 2 terms together and the last 2 terms together. And it's essentially the GCF method 3 different times. So we're going to do the find the GCF rather of the first group. So both of them have at least 2 x's, so x squared. A little tip, you just always take the smaller exponent. And they both have a y. So the GCF of the first group is x squared y, right? So let's actually just focus on group number 1. So again, factoring using GCF method, you're going to set that GCF on the outside. There are 2 terms that we're factoring. So there's going to be 2 boxes, and we're going to reverse distribute. So x squared y times what gives me 7x cubed y? Well, we're missing a 7. Product rule says I need to add the exponents. So I have 2. I need 1 more to get to 3. And there's already a y. No need to add another y there. And now x squared y times what gives me the 2x squared y. Well, I need a 2, a positive, right? Because a positive times a positive is a positive. X squared, we already have it. And look at that, it already has the x squared y. So actually, we're done with that group. Now, group number 2, I can do in purple here. So what is the GCF of this group? Well, they are both divisible by 6, and they both have a y. So I'm going to pull out a positive 6y. So make sure you put that plus sign. It's super important. So group number 2, we're going to set up as the reverse distributive property, 2 terms, so 2 boxes. So 6y times what gives me 42xy? Well, 6 times 7 is 42. I have a y, but I'm missing an x. Now, so by the way, y times x is the same thing as x times y, right? Because of the commutative property. So that is correct. And then 6y times what gives me 12y? Well, 6 times 2 is 12, right? I need a positive number. Positive times a positive is a positive. And that's it, because it already has a y. No need to add more. So you know you're doing it correctly. The goal when you factor by grouping is we should end up with matching parentheses. So essentially, we're going to be pulling that out of both 2 terms. So whenever you have matching parentheses, people like to write that matching parentheses first, although it doesn't matter because of the commutative property. And then in the second exponent, I like to just circle what's left. So it's going to be x squared y plus 6y. So I'm not going to do it here, but it turns out that if you were to FOIL or use the distributive property, and you maybe might have to rearrange it a little bit, you do get back the original. So the next one, right, first step is you should always scan for GCF. Nope, none of those 2 terms have anything in common. Then you ask yourself, okay, how many terms are there? There are 2. So whenever there are 2 terms, right, so it's usually either GCF method, which it's not, and then either difference of perfect squares, or it could be sum or difference of cubes. So how do we know what is A and what is B? So like the difference of perfect square, A has to do with the first term and B has to do with the second term. Instead of taking the square root of the first term, now we're taking the cube root of the first term. And instead of the square root of the second term, it's going to be the cube root, right? So instead of asking yourself what times itself 2 times, right? That's perfect square. Now you're asking yourself what times itself 3 times gives me 64x to the third, right? So what is the cube root of 64? That's 4. So 4 times 4 times 4, right? And then the cube root of x to the third is x. X times x times x. B is going to be the cube root of 27. That's 3. 3 times 3 times 3 is 27. So the easy thing is now you just pop that right into your formula. So where it says A plus B, well, if A is 4x and B is 3, right? I'm just going to use that substitution. In the second parentheses, I'm squaring A. So be super careful. You should be putting parentheses around the 4x, right? Because people might say that's 4x squared. Not true. That should end up being 4x times 4x, right? That's what it means to square something. So that's actually 16x squared. That's a very common mistake. Then you are subtracting by the multiplication of A times B. 4x times 3 is 12x. And then you're adding it to squaring B. 3 squared is 9. That is your final answer. And it turns out a little shortcut whenever you do sum or difference of cubes, you actually cannot factor it anymore. So if you try to factor this one, it will never be factorable if you want to use like the AC method, for example. All right, speaking of the AC method, so first things first, we went over GCF method, sum and difference of cubes, difference of perfect squares, and factor by grouping. Another tool in our toolkit is the AC method. Now, the AC method, it has to be 3 terms, right? That's what trinomial means. and it has to be quadratic. Quadratic means that it has to be to the second power maximum. That's what degree means, the highest exponent, right? And then again, as I said, it has to be 3 terms. If you have these 2 criteria met, a bell should go off in your head that it could be the AC method. So when I'm talking about A's and B's and C's, I am talking about of standard form, right? So as we can see, A is the number in front of the x squared always, even if it's rearranged. B is the coefficient or the number in front of x, and then C is always the number that does not have an x attached to it. It's called a constant. So once you identify A, B, and C, then I'll talk about what the AC method actually is. So first things first, I would always recommend you write A equals B equals C equals. Just identifying makes it your life easier. So A is the coefficient or the number in front. Don't say x squared. That imaginary number is 1. B, be super careful, is a negative 14. And C is going to be a positive 24. So now, what is the AAC method and why is it called the AAC method? Well, because you're doing A times C. And then we're going to do a factor tree of that. So A times C, so I like to do it this way, right? So we're multiplying A and C together. So that's 1 times 24. That's positive 24. And now we're going to do a full factor tree of that. And what I mean by full factor tree is making sure that you also account for the negatives. So in other words, yes, a 2 times 12 is 24, but also a negative times a negative also gives me a positive. So be super careful about that, right? So if I were to just keep going down the list, like another one that I can think of is 4 times 6 and then negative 4 and negative 6, right? You can also do the pair of 1 times 24. But I'm actually going to stop here because the golden answers here, or should I say the golden factors here, I already see on that list. How do I know which one I'm going to choose? Is once you do your factor tree of A times C, you're looking for the ones that add up to B. And the ones, and so B is negative 14, right? So which one of these adds up to negative 14? These guys, right? Negative 2 plus negative 12 gives me negative 14. If I add these 2 together, that gives me positive 14. If I add 4 plus 6, that gave me 10. If I add negative 4 and negative 6, that gives me negative 10. So again, I want the ones that add up to B. So now, the beauty of factoring a trinomial where A equals 1, so I'm going to put a star here, or I'm going to just circle this, right? What we love about A equals 1 problems is that there's a nice shortcut. And that shortcut is you're always going to plug it in the template. So it's going to be 2 parentheses next to each other, right? 2 binomials. And you'll always set up as the first terms are just x. And then what's nice about it is these 2 factors here that we found, because those are both negative, I'm going to write minus 2 and minus 12. Done. Okay, so again, for A equals 1 problems, once you pick your factors, you just pop it right in that template. And if you did a check and foiled it out or distributed and combined like terms, you do get back the original, right? So I'm not going to do that here. Oops, I almost forgot. We're not factoring this. We're actually solving for x. So remember, the original problem is it's equal to 0. So once you get it in factored form, right? That was factored form set equal to 0. Now what you're always going to do is you're going to, I like to kind of do a little split here. You're going to set each expression inside the parentheses equal to 0. So I'm going to set x minus 2 equal to 0 and x minus 12 equal to 0. Yes, they're 2 separate equations because they're going to have 2 different answers. So over here, I'm going to add 2 on both sides. So one of the solutions is positive 2. And over here, I'm going to add 12 to both sides. And the other solution is going to be 12. All right, so now we're solving this equation by factoring. So the very first thing I should have said before is actually always double checking that it's set equal to 0. In this case, we can see it's not. So what happens if it's not set equal to 0? We're going to make it equal to 0. And we're going to do that by performing the opposite operations, right? So negative 2 plus 2 is 0. So we accomplished that. And now those are not like terms. So I'm just going to copy that. So that's 2x squared plus 5x plus 2. Now we have the equation set equal to 0. So we're going to factor that. So again, it's 3 terms. The highest exponent is 2. So this is promising to be the AC method. So very first step before you do anything is you need to identify what's A, B, and C. So A is the coefficient of x squared, B is going to be the coefficient of x, and C is the constant. It has no x attached to it. Now we're going to multiply A times C. So 2 times 2, which is 4. Once you multiply A times C, that's what we're going to do a factor tree of. So what do they multiply to get to positive 4? And again, don't forget a negative times a negative also, right? Or we could do a 2 times a positive 2 or a negative 2 times a negative 2. So again, the factors of A times C add up to B. That rhymes. We want to look for the factors that add up to B, which is positive 5. That's those guys. Okay, so unfortunately, A does not equal 1 here, like the previous problem. A is 2. So only for A equals 1 problem can we use that beautiful shortcut. So how do we do it if A does not equal 1? So what we're going to do is we're going to take this original trinomial, right, 3 terms, and we're going to convert it to 4 terms. Why would we want to do that? Because remember from earlier, when you have 4 terms, you're going to end up factoring by grouping. So how are we going to use these 2 chosen factors to then convert it to 4 terms? So the next step is you're going to take that middle term, positive 5x, and you're going to split it up into 2 terms. And you're going to do that by writing the factors as coefficients. So in other words, 1x plus 4x, right? Does that equal 5x? So now I'm just going to rewrite this polynomial. So that's going to be 2x squared. Now I'm going to do the split. Now, could I do 4x plus 1x? Or 1x plus 4x? Sure, the commutative property. So it doesn't actually matter which one you do first. So maybe, I don't know, since I wrote this one first, I'll just do it that way. So, and I don't need the x. If you want to put that there, that's fine, right? And then I'm going to drop down the plus 2, right? So we didn't actually change the polynomial. We just converted it to 4 terms. So now we can factor by grouping. And again, to factor by grouping, you're going to find the GCF of the first term. So both of group number 1, they have an x in common. So I'm going to pull that out, right? And again, it's like the distributive property, right? This GCF here is x. So x times what gives you 2x squared, 2x. And x times what gives me itself positive 1, right? So the next one, what do both of those terms have in common? Well, they're both divisible by 2. So make sure to put that plus sign in between. We're pulling out a positive 2. 2 times 2x gives me 4x. And then 2 times positive 1 gives me 2, right? And then this is set equal to 0. So don't forget, you're not done yet, right? Remember, factor by grouping. Once you have those matching parentheses, which means you know you did it right, that tends to be the one that people like to take out first. Right? So you just write rewrite the matching parentheses, and then the other parentheses is going to have whatever's left. So I just like to circle them, right? And so that goes in here, set equal to 0. Okay, so how do you solve any factored form equation set equal to 0? You're always going to set separately each expression inside the parentheses to 0, and you're going to solve 2 completely separate equations. So on the left side, right, we're going to be subtracting 1 and then divide by 2. So you can write x equals a half, or I'm sorry, negative a half, or you could write negative 0.5. Doesn't matter, right? And then easy, the one on the right, you just subtract 2. So these are the 2 solutions. All right, number 6. So how do you simplify a radical expression? So I did write a hint here that you're going to find the biggest perfect square factor. So on the side, we're going to simplify them separately. And actually, let me back up a little bit. How do I know? Can I just add 27 and 48 and stick a radical on it? No. You can do that for multiplication and division, but when you're adding and subtracting radicals, they have to be like terms. How do you know they're like terms? That they have to have the same number inside the radical, called the radicand, which they don't. So then you're asking yourself, can I simplify it separately? So what you're going to do, right? Let's not look at the radical 48, is you're going to do a factor tree, but make sure that both of them are in radicals because they're in the radical family. So what times itself is, I'm sorry, what times what is 27? Well, 1 times 27 works. That's not going to be very helpful. One of the factors has to be a perfect square. I like to write the perfect square first. You don't have to. Right? 9 times 3 is 27. I know that 9 is the perfect square because what's the square root of 9? 3. So the whole point is one of the factors ends up breaking out of the radical, and that one that breaks out of the radical is a perfect square. So actually, that's not the final answer. I take that back because now we got to do the other guy here. So same thing is we're going to split it up. What is the biggest perfect square factor that goes into 48? Why did I say biggest perfect square? Because 4 is a perfect square and that goes into 48. We want to figure out what's the biggest perfect square. That's 16. And the reason why I say the biggest perfect square, why couldn't we do the 4? Just because it's going to be more steps and people will tend to mess up more on that one. Okay, so the square root of 16 is 4. And then drop down the radical 3. And remember, the original problem was we're really adding everything, right? So now look what happened. These end up being like terms because we talked about they have to have the same number inside the parenthesis, inside the radical rather. So you could just add the whole numbers, right? So 3 plus 4 is 7, but you're not going to say radical 6, which is a common mistake. You're just going to keep the radical the same. So now what happens when you have a negative inside the radical? So you're going to do the same thing as before. You're trying to find a perfect square that goes into 20, but there's actually going to be another stem. So we want to pull out a negative here. So let's just focus on the perfect square. So I know that the square root of 4 times the square root of 5 gives me square root of 20, right? So that's positive 20. How do we make it negative 20? We're going to multiply by negative 1. Why did I do that? And first of all, why did I put the negative 1 in the middle? That's just because when we write the radical, or when we write the final answer, it just makes it a lot easier for us. So first of all, if you remember, or if you didn't learn it at all, I stands for imaginary number, and it is defined as the square root of negative 1. So that's why you're always going to, when you have negative inside the radical, you're just going to always pull out the negative 1. So making that substitution, the square root of negative 1 is I. The square root of 4 is 2. And then 5 is not a perfect square, so you're just going to leave it as radical 5. So we always write the whole number first, and then the I in the middle, and then the radical last. That's why I like to write the negative 1 in the middle. All right, so now we have lots of stuff going on here. So people might think, oh, 2 and these are all divisible by 2. Great, let me just divide all those by 2. No, you can't do that for 2 reasons. Number one, the only way that you can, let me see if I can make that bigger. The only way that you can divide is it has to be 1, 2, and this imaginary whole number in front here. Those have to be divisible by the same number. Obviously, 2 and 8 have something in common, but the 1 does not. Let's say if the original problem was 2 radical 2, for example, then you can divide only those whole numbers by 2. Unfortunately, you can't touch the radical 12, even though 12 is divisible by 2. So that's reason number 1. Reason number 2, I actually just said it, is because these are whole numbers and that's a radical. So they're not like terms, if you will. So how do we do this? you always want to look to see if you can simplify the radical. Now, I like to do that on the side first, and we just went over these types of problems. What perfect square goes into 12? 4. 4 times 3, right? So then the square root of 4 is 2, right? So the whole point is that the perfect square always leaves the radical. So now I'm going to make that substitution back here, right? So I'm going to rewrite it and say 2 minus 2 radical 3 over 8, right? And so now look what that does. Now you recognize all 3 whole numbers are divisible by something in common, in this case 2. Now you can do it, right? So the difference before is now you have a radical 3, right? So 2 divided by 2 is 1. 2 divided by 2 is 1. So that's going to be radical 3. And then 8 divided by 2 is 4. Now, do you need that 1 in front of the radical? No, but we can leave it. So next section, we have adding, multiplying, and dividing fractions. So notice I purposely left a little bit of space here. And that's because in order to add and subtract fractions, you need to have common denominator, which they don't here. So you're going to find the least common denominator. So you can just multiply the denominators. So 5 times 7 is 35. So what would I have to multiply here in order to get 35? 7. And just make sure you do it top and bottom, right? What would I have to multiply in the second fraction to get 35? Is I have to multiply by 5. So now following PEMDAS, right, you always multiply before you add. So you should be simplifying those first. And how do you multiply fractions? Straight across. So 2x times 7 is 14x. And then 5 times 7 is 35. Same thing, I'm going to multiply straight across. So that's 25 over 35. Now we've accomplished common denominators. So what's there left to do when you have the common denominators? Now you're going to just add the, combine the numerators. I should just put it that way, right? So the final answer is 4x plus 25. Those are not like terms. So we're just going to leave it all over 35. Now, the last thing to do is just make sure that it's in simplest form. And the way to do that is you have to make sure that all 3 whole numbers here are divisible by the same number. They do not have, there's no greatest common factor here. So this is actually going to be the final answer. Multiplying fractions we already talked about before. So multiplying, we're going to multiply straight across. 2x times 5 would be 10x. 5 times 7 is 35. Now always make sure that it's simplified, or at least it probably will say it in the directions. And both 10 and 35 are both divisible by 5. So 10 divided by 5 is 2. So that's going to be 2x. 35 divided by 5 is 7. And that is our final answer. If you want, you can always scoot the x to the side. So that's another way you can write it. So by the way, if you want to get more details on how to do any of this stuff that we've gone over so far, as a matter of fact, every problem on the pretest, you can find in my course where I go over everything really extensively as a lesson. And you have homeworks, modules, tests, quizzes, all that stuff. Okay, so now dividing fractions is keep, change, flip. So we're going to keep the left. We're going to change the sign into multiplication, and then we're going to flip, aka find the reciprocal of the last fraction. So that's going to look like 2x over 5 times the flip, which is 7 over 5. And again, that gets us in a scenario where we do know how to multiply fractions straight across. So that is going to be different from the last problem, because now it's going to be 14x divided by 25, just making sure I move my face out of the way there. And then make sure that the 14 and the 25, there's no GCF. They have nothing in common. So that's going to be the final answer. Now we're going to get into rationalizing the denominator. So right now the denominator is irrational and we want to make it rational. But how do we do that without actually changing the value of the final answer? So it turns out you can actually multiply by 1, right? Anything times 1 is itself. Well, 1, I could do 1,000 divided by 1,000. That's 1. I could do, I'm just picking random numbers here, 567 divided by 567, right? These are all 1. So if you've noticed, anything divided by itself is 1. But I'm going to pick a very special number, right? Because it could be anything as long as they're the same top and bottom. But I'm going to multiply by whatever's in the denominator, right? Radical 3 divided by itself is 1. Now let's see what that does, right? So we're going to multiply straight across as usual. Now be careful, 3 and radical 3 are not like terms, quote unquote. One is a whole number, the other one is a radical. So the best way you could write it is just 3 radical 3. Right? Because there's an imaginary multiplication symbol that's keeping those two together. Now here's the catch. The square root of 3 times square root of 3, those are both radical. And in multiplication, it's totally legal if you do multiply the numbers inside. Remember, adding, for it to be like terms, they have to have the same number under the radical. Multiplication is different. That you can actually just multiply whatever's inside the radical. They don't have to be the same number. So that's going to be the square root of 9. So the whole point is to get a very special number under the radical. If you've noticed, that's actually a perfect square. The square root of 9, so whenever you have a perfect square, it breaks out of the radical. That's 3. Now look what happens. We just rationalized it. So if you put 3 divided by square root of 3 on your calculator, and then you put 3 times radical 3, and then click divided by 3 on your calculator, they're going to be the exact same decimal, which is really cool. Now, you do always want to keep your answer in simplest form. So again, the quote-unquote like terms, you cannot divide all the numbers by 3, right? Notice that they're all divisible by 3. The only quote-unquote like terms are the whole numbers. So you can only do 3 divided by 3 is 1, and then 3 divided by 3 is 1. So you're going to leave the radical alone. So technically, this is 1 times radical 3 divided by 1. You should be able to get maybe full credit. It depends on your teacher, but technically, to totally simplify it, anything divided by 1 is itself. So that would be the more complete answer. And then you don't have to put the 1 in front of the radical 3, right? Because 1 times anything is itself. So you could just simply put radical 3 as your final answer. All right, so this section is solving equations and inequalities, right? So I go through all of these in detail in my lessons in my course. I can leave that link in the description. So whenever you do inequalities, they're pretty much going to behave just like equations. So if it helps you, you can absolutely, for the time being, pretend that that's an equal sign, but so important, you have to make sure that you put it back, okay? So you would normally do this by combining like terms, right? The both whole numbers. The opposite of subtracting 6 is adding. And then 14 plus 6 is 20, right? And then the opposite of multiplying by 5 is dividing by 5. So if this was an equation, obviously you would get x equals 4, but be super careful. That was not the original problem. So just make sure to put the inequality sign back. Now be super careful. I do want to say something. Let's say, okay, I'm totally changing the problem for a second. Just bear with me. Let's say this problem was a negative, right? So let me drop down. So we were really dividing by a negative. Super important. When you multiply or divide by a negative number when solving, the inequality sign flips. So this would actually end up being x is greater than 4 rather than x is less than 4. I'll repeat that again. When you multiply or divide, only those two operations, when solving an inequality, the inequality sign flipped, okay? But we divided by a positive number, and so it is going to be consistent with the inequality sign that we started. So there's infinite solutions here, right? There's any number that's less than 4. Now, honestly, when I teach a class, I'm not too picky. As long as the number 4 would be on the number line, that would be great. Now, other teachers might have you, do other numbers, whatever, it doesn't really matter. Now, when you graph inequality signs, what you also have to keep in mind on is whether I'm going to put a closed circle or an open circle. A closed circle or an open circle on 4. How do you know that? So if it's not underlined, which it's not in this case, it's going to be an open circle. Now, what that means is that 4 exactly is not a solution, right? That says x is less than 4, not less than or equal to. So if there was an underline underneath here, then you would put a closed circle, and that would mean to the person reading the graph that, hey, 4 is an answer too, right? And then on the number line, which are all the numbers smaller, because that says less, x is less than, you're going to shade all the numbers to the left. So we're going to do the equation section. So that is saying 2/3 times x, doesn't it? So what's the opposite of multiplying by 2/3? So there's 2 ways you can go about it. You can do divided by 2/3, right? The opposite of multiplying by 2/3 is dividing. So the 2/3 cancel. This is the most popular way that I see people doing it, so that's why I'm going over it. And then let me just write it this way. That says divided by 2/3, doesn't it? And that's going to be similar to the problem we did before. When you divide fractions, we are going to keep, change, flip. But wait a minute, 56, that's a whole number. That's not a fraction. Well, you're going to put it over 1, right? Now, how do you divide fractions? As we said, you're going to keep, change, flip. So you're going to keep the first guy, you're going to change the sign to multiplication, and the 2/3 is the one that you are flipping. Okay, and that turns into, I meant to put this over 1, right? That turns to multiplying fractions. How do we do that? That's going to be straight across. Now, well, let me just finish doing this way, because I know many students' brains work differently. Okay, so I'm just going to do the old-fashioned way that you multiply straight across. So a negative times a positive is a negative 168, and then 1 times 2 is 2. And then what's 168 divided by 2 and negative divided by positive? That's going to be negative 84. So that is the most common way that, that I see people go about it. If you've done it that way, cool, you can just skip ahead, but I want to show different methods. First of all, let me go back over here. There is a shortcut when you multiply fractions that I didn't talk about yet. And that shortcut is that you can look diagonally and see if they have a GCF. You're not cross multiplying, which is what people do. That's when you solve an equation. That's a multiplication symbol. So as I said, you're not cross simplifying. You're not cross multiplying. You're cross simplifying. So 3 and 1 have nothing in common, but 2 and 56 diagonally, the GCF is 2. So you're going to divide that out, right? So 56 divided by 2. So that was going to be negative 28. And then obviously 2 divided by 2 is 1. Now, what does that do? You work with smaller numbers now. That's really the gist, right? So again, now we're multiplying smaller numbers. So now you're doing 28 times 3, which, and a negative times a positive. Surprise, surprise, there's that negative 84. And then 1 times 1 is 1. And again, anything divided by itself, by 1 is itself. So we get the same answer. So if you'd rather work with smaller numbers, I don't know if your teacher's going to make you do things without a calculator, cross-simplifying would be a great skill to have for sure, especially when you get to pre-calc. That's going to come a lot. And not even just pre-calc, other, I think, yeah, pre-calc, algebra 2 trig, that type of, those types of classes. All right, so the other way is when you're multiplying by a fraction. In this scenario, the third method is you multiply by the reciprocal, okay? Multiply by the reciprocal. And again, reciprocal just means you're flipping. So when you multiply by the reciprocal, so we're going to multiply by 3/2, and obviously make sure whatever you do on one side, you always have to do the same exact thing on the other. What that does is it could kind of just kills 2 birds with 1 stone here. That's such a mean, that's such a mean like expression. But so what that does is, again, just talking about that cross simplifying, you can actually cancel out the 3's, and hey, the 2's cancel out as well. So it just gets the x by itself all in one shot. And then again, if we put 56 over 1, right? So let me just rewrite it. We get right in the same spot. We're going to skip the whole key change flip idea in your brain. What that does is it does it for you. So when you multiply by the reciprocal, in the process, it keep change flips for you, okay? And then I don't have to go over how to solve this because we just did that. All right, so this is solving, I would say this would be a two-step linear equation. So before we were solving equations in one step. Now, what happens when you have a couple of steps? It's pretty much just moving terms around, so that way you get all the like terms together. So some people might have seen, you can imagine that the equal sign is like a wall. And a lot of people like to stay organized just by making sure that equal sign stays in line. You don't have to do that, right? So we have a left side of the wall and a right side of the wall. Now, what's cool about when you do problems like these is it actually does not matter which one moves, right? So there's like 4 different ways. I can move the x, I can move the -15, the 2, right? Doesn't matter. So in this particular case, I don't know, maybe I could just move the x. Now there is an imaginary plus sign in front of there. So what's the opposite of adding x? Subtracting x. And notice that I'm stacking it under the like term with the 2x, right? Notice I didn't stack it under the -27. I mean, you can, but it just makes life a lot easier, right? So now on this left side, we end up with -15, and then combine like terms, 2x minus 1x is just 1x or just x, and then drop down the -27. Now we got to get the whole numbers together. The opposite of -27 is adding 27, right? And I know that you're technically really subtracting here, and the 27 sign is positive. So I know my final answer is going to be positive because it's bigger than 15. I talked about that at the beginning of the video. And we are done. All right, so let's kick it up a notch here. What if you have something like this? Now, sometimes it helps to just say it in your head what's going on. So you have -3 times, right? Both guys there, 4x and the -8. So you want to distribute here. So -3 times 4x is -12x. A negative times a negative would give me a +24. And that's it, right? Try and make sure you stack the equal signs, stay organized. Organization is pretty much key. And then it turns out it looks just like the previous example, right? So you got to get those like terms together. So the opposite of adding, is subtracting on both sides. What you do to one side, you do to the other side. I'm going to drop down that -12x equals, and then when you're doing same signs, you're always technically adding, but a negative and a negative, it's going to stay a negative, right? And then that says times -12. So you're going to divide by -12, and negative divided by a negative is always going to be a positive, right? And so on a test or a quiz, it's always helpful to do a check, right? So if you were to, I'm not going to show it here, but if you were to stick the 5 in the x spot, right, and use PEMDAS, you'll see that it should equal -36. So that's a way that you can check your answers. All right, we're going to keep kicking it up a notch. So you don't have to do the wall. That's just for organization, right? Just making sure that when you have like a lot of stuff that's starting to go on, it could be helpful to just visualize, okay, what's on the left and what's on the right. Because a lot of times I see students they're subtracting on one side and then they accidentally, because the expression's so long, they do it twice on one side. Nope, it's got to be one on one side and one on the other. So you're always looking to, we have addition here, and then we have a multiplication going on, right? Technically, PEMDAS, you want to see inside that group there, but they're not like terms. So we always multiply before we add. So you should be looking to distribute first. And whenever you do PEMDAS problems, again, you've got to stay organized. We're not touching that. We're dropping that down. 2 times 5x is 10x. And then 2 times -6 is -12. Okay. And then the other side, I didn't touch anything there. There's nothing to, they're not like terms. There's nothing to do on that side. So I can just drop that down, right? So now what that does is the parentheses is gone. Now we can add and subtract like terms. So only these two are like terms. They're both in the x family, right? So -4 plus 10x, you're just doing -4 plus 10 essentially. That's going to be 6, but again, that's in the x family. We're going to drop down that -2. And again, we're just going to keep, bringing everything down. Now this looks like, right, we've seen this before. So again, it does not matter which guy moves first. Some people might, look at the 6x and the negative 3x and they might say, maybe I like keeping stuff positive. Maybe I can add 3x on both sides. Notice I'm stacking like terms. 6x plus 3x is 9x. And then just drop everything down that we didn't touch. Last but not least, we have to get the whole numbers next to each other. So we have 9 times x is equal to, so we're technically subtracting there with opposite signs, and 39 is bigger, so I know that it's going to be a negative number. Only one more thing to do. Divide both sides by 9, which is opposite of multiplying, and we do get x equals negative 3 as our final answer. All right, so we're solving another equations here, but both are fractions. Now this is called a proportion when you have a fraction is equal to another fraction. So how you solve proportions is you cross multiply. That's different from cross simplifying. Simplifying diagonally is when you multiply fractions. When you are solving an equation, there's an equal sign there. That's when you're cross multiplying. And that simply means that yes, you're going to look diagonally there. You're not looking to simplify anything. You're looking to multiply them. And then you're going to set the products equal to each other. Now, does it matter which diagonal you multiply first? No. So 4 times 2, I guess I could just write everything out, right? So that is going to be equal. Now, super important. People tend to make this mistake all the time. You better put that x plus 2 in parentheses, right? Because you're multiplying by the entire numerator of the equation. That's a binomial there. So the part that people miss is then you should be distributing that 3, right? So 4 times 2 is 8, distributing there. So we get 3 times x plus 6. We're going to get those like terms together by subtracting, which is opposite of adding. 8 minus 6 is 2 is equal to 3 times x. The opposite of times 3 is dividing by 3. And so you can just leave your answers as 2/3. In Algebra 2, we don't care about fractions or improper fractions when the bigger numbers up top. A lot of times we just leave it as fractions. But, if your teacher said round to the nearest 10th or whatever, just make sure to read those directions. Okay, so adding fractions, notice I left a little bit of space on purpose. We've done this before, except with x's. No, actually, I take that back. We already did it with x's. But the difference here is now we're solving an equation, not just simply simplifying an expression, right? So again, we need the least common denominator. So what do both denominators, what could the LCD be? You just multiply the denominators, that's all. So 2 times 3 is 6. So that would mean to get to 6, I'd have to multiply, again, be careful, must be top and bottom. So I'm going to multiply that guy by 3's. And for here, I'm going to have to multiply by 2's here. Now, again, just make sure you always multiply before you add in PEMDAS, right? And how do you multiply fractions? Straight across, right? So 2x times 3 is 6x. 2 times 3 is 6. Drop down that plus sign, x times 2. I can just rearrange that and write 2x. 3 times 2 is 6. Look at that. We have common denominators successfully. Drop down, that equals 3, right? So the whole point is getting common denominators. So when you accomplish that, you can just simply combine the numerators, in this case, adding them together, right? If there was a subtraction, you would subtract them. So those are like terms. I can combine them to do 6x plus 2x, which is 8x. Keep the denominator the same. That does not change. A lot of students I see accidentally for some reason, they like multiply 6 times 6, or they add 6 and 6. So they'll put 12. Don't do that, right? Adding and subtracting fractions, the denominator stays the same. Right? And so now how do we get that whole number to get 6 together with the other whole number 3? So the opposite of dividing 6, so you're going to be multiplying both sides, right? That's the opposite of division is multiplication. So what that does, technically, if you want, you can put this over 1 and see cross simplifying, right? Diagonally, they're both divisible by 6. So if you want, you can do 6 divided by 6 is 1. Or notice when they do match, you could just cross them out, right? So that 1 is imaginary. It's not necessary. So we end up with just 8x, and then 3 times 6 is 18. Opposite of multiplying is dividing. So our answer is 18 over 8, but be careful. Most often than not, you're definitely going to have simplifying it in the directions. Make sure to read that. So the GCF is they're definitely divisible by 2. Both of them, right? So your final answer is going to be 9/4. And again, in Algebra 2, don't be scared of improper fractions. We don't like mixed numbers. I don't know why, or I shouldn't say anything. I was going to say, I don't know why they even teach you mixed numbers because we never use that in higher math. So just take mixed numbers out of your brain. And then again, if your teacher says round to the nearest 10th, you could just do 9 divided by 4 and round. All right, so quadratic formula obviously is just for quadratic equations. Quadratic equation means that the degree or the highest exponent is 2. I've seen people do quadratic equations when you have or quadratic formula rather, to the 3rd power, 4th power. No, it's called the quadratic formula because it's only used for quadratic equations. So that's one method to solve for quadratic equations, right? So we've seen you can solve by factoring, and you can even solve by completing the square, which we'll do later. Those options, completing the square and quadratic formula, is just for quadratic. Okay, I'm done with repeating. So in order to do quadratic formula, super important is it must be equal to 0, okay? If it's not equal to 0, you have to make it equal to 0. How do I do that? Well, there's that -1 on that right side, and the opposite of subtracting, I don't know why I added it to 0. The opposite of subtracting is adding, right? So those 3 terms are not like terms, right? Because for it to be like terms, the exponents have to be the same. So I'm just going to write it like that, right? And then look at that, we got it equal to 0. So now that we have it set equal to 0, we can now identify what A, B, and C is. If you recall earlier, what is A, B, and C? A is always the coefficient of the x squared term. B is always the coefficient of the x. And C is called the constant, meaning it does not have an x attached to it. So again, I would recommend, I at least have my students just make sure you can get credit just by identifying A, B, and C. Literally. So the coefficient of x squared is 4. Be super careful. That middle coefficient there is a negative, and then C is +1. Now, what's really nice about identifying A, B, and C so clearly is that you can just pop it right into the formula. So I don't know why it switched to yellow. Let me how about blue? Okay. So now -b means doing the opposite sign, right? Or in other words, oh, that's why, because it's under just kidding. Okay. So that's if I substitute -8 in the B spot, right? So that's actually saying -8. And when you have 2 minuses next to each other, it just makes it positive. So when you see the -b, just do the opposite sign. Okay, so that should be +8 plus or minus the square root. All of it is under the square root. You're going to be squaring B. Now, a very common mistake is I see people not put -8 should be in parentheses. It better be, because if it's not in parentheses and you're doing it on your calculator, it's going to give you the value of -64, and it should be positive, right? Because that says -8 times negative, which is a positive. Again, I go through all of this in detail with my course. So -4 times A, which was 4, and then times C, which is 1. Now, a super common mistake I see is people might just put that as the numerator, but be careful, it's all over. That's the entire numerator of the fraction, and that's 2 times A, which is 4. So let's take a look at the -8 being inside the parentheses versus outside the parentheses. So putting it inside the parentheses, that means you're squaring -8. So negative times a negative is a positive. But watch what happens when we put it outside the parentheses, you get negative 64. And the reason why it does that is because it's reading PEMDAS. It's reading as positive 8 being the base of the exponent. So it's doing 8 squared, which is 64, and then it's going to be doing the negative of that. So if you just make sure that you always put it in parentheses anyway, you don't have to worry about a thing, right? So if we put negative 8 squared in parentheses, make sure another common mistake is you put a minus sign, so -4, instead of people might accidentally be putting -4, and people will get tripped up on that. So if you do the square root of 48, if you notice, it's going to be a decimal. And what that means, if you're asked in the directions to do it in simplest form, is you should now be looking to simplify square root of 48. If you're asked to round to the nearest tenth, then that's fine. So to recap, whenever you're asked to give an answer in simplest radical form, if you noticed on the calculator, I did not do the square root, you only do what's underneath the square root, which is called the discriminant, by the way. And it cracks me up when people freeze on, oh, what does simplest radical form mean? It literally has the word radical in it, which means your final answer should have a radical in it. Radical is square root, by the way. So do not put the square root in the calculator. If the direction said to do it to the nearest tenth, then yes, then you would put it on your calculator. But we want to do simplest radical form, so we want to actually leave the radical in our final answer, right? So another common mistake is people might say, oh, look, 8, 8, and 48, those are all divisible by 8. Let me just divide everything by 8. You can't do that, because if you remember, I went over earlier, all 3 whole numbers has to have something in common. And if you're asking yourself, wait, where's the third whole number? I see 1, I see 2. It should be the number in front of the radical. Right now, there's an imaginary 1. That's the third whole number I'm talking about. So if you notice, because of that 1, now 1, 8, and 8, there is no GCF. So you cannot divide by 8. The second reason people might get tripped up on why you cannot divide the radical by 8 is because the whole number and the radical are not like terms, if you will. Okay, so you cannot touch what's inside the radical. So what are we supposed to do? As I said earlier, we're going to be simplifying the radical, which is what we did before, right? So you're looking for the biggest perfect square that goes into 48. Yes, there are there's I think 4 goes into 48, but also 16 goes into 48, and 16 is the bigger perfect square that goes into 48. You can do 4 and 12, right? Those work, but the thing is, then you can split up the 12 into 4 times 3. And if you're like, huh, what the heck did she just say? That's exactly my point. So to just not worry about all of that, because people get tripped up on that, just pick the biggest perfect square that goes into 48, which is 16. So now the entire point of picking a perfect square is it breaks free out of the radical. 3 is not a perfect square, so I'm just going to leave that as 4 radical 3, right? How do we know, by the way, that we are done and we simplified it all the way? Is the number underneath the radical, you ask yourself, is there a perfect square that goes into that? And the answer is no, right? So you know it's simplified as much as possible. So now we know radical 48, right? If you do square root of 48 on your calculator, and if you do 4 times square root of 3 on your calculator, you're going to get the exact same decimal, okay? So we're not really changing the value of anything. This is all valid. So now look what happens. We now have a scenario where all 3 whole numbers have something in common. In this case, they are divisible by 4. Now we can absolutely take those 3 guys and divide everything by 4. So 8 divided by 4 is 2. 4 divided by 4 is 1. 8 divided by 4 is 2. So you do not have to put the 1 in front of the radical 3, but if you want, knock yourself out. So we're going to leave this as our final answer. So again, if you're asked to round to the nearest tenth, then you would just put all of that in your calculator. A third way you can solve quadratic equations besides factoring and quadratic formula is completing the square. Now, unfortunately, you're going to have to memorize the process, or at least most teachers do. And so when I'm referring to A, B, and C, again, I'm referring to the fact that A is the coefficient, so it's the number in front of the x squared. B is the coefficient of the x term, and C is the constant. In other words, it does not have any x attached to it. All right, so the very, very first step when you complete the square is making sure that the leading coefficient, in other words, that A value is 1. And as we can see on this example, A is not 1, it's 2. So if it's not 1, you have to make it equal to 1. How do we do that? Well, remember this is 2 times x squared, so we can divide by 2, because 2 divided by 2 is 1. But the catch that people mess up on is the fact that you have to divide every single term by 2. Okay, so now when we simplify, we have x squared minus 10x, minus 5x, just kidding. 6 divided by 2 is 3, and then 0 divided by 2 is 0, right? So now the second step for completing the square is you have to move the C value to the other side of the equation, okay? So what is the C in this particular case? It's positive 3. So how are we going to move it to the other side? Well, the opposite of adding 3 is subtracting 3. Now, this is the step where I like to put boxes, or you can leave a little bit of space. So we're going to get ready to add the exact same number on both sides of the equal sign. And then 0 minus 3 is negative 3, right? So I like to add a box on both sides. Now, let me just stop for a second and say that as long as you add the exact same number on both sides, you're not actually changing the value of the equation. I can add 100 to both sides. I can add 27 to both sides. I'm just picking any random number. But what we're going to do is we're going to we're going to add a very special number, a very specific number to both sides. And there's going to be magic that happens there. So the very first step is what is going to go in that box. So what you're going to have to memorize is you're going to cut B in half, right? So the B value. And then you're going to square it, okay? So that is going to produce us a very special scenario. But before we do that, right? So the B value is negative 5. So on your calculator, divide by 2, that's negative 2.5. And then you're going to square it, right? Squaring something means multiplying by itself twice. So negative 2.5 times a negative 2.5 is going to give us a positive 6.25. Now, I do just want to add that whenever you do this step, you better always get a positive number, because when you square a number, it's always positive. So what does this do? Now, this is what is called a perfect square trinomial. It's a trinomial, right? 3 terms, but it's called a perfect square trinomial because it's something squared, right? That's where that perfect square is. Because we're going to take the square root of that later, and what happens is whatever's inside the parentheses is going to break free, right? So the template is always going to end up being x plus or minus, depending on the problem, this box, right? So step number 3, right? That is what goes in the first set of boxes. Now step 4 is, well, what's going to go in this box? Okay, and it's going to be connected to what we did before. So first things first, let me finish. We have to simplify the other side. Negative 3 plus 6.25 is 3.25. Okay, so now we have to figure out what goes in that box. So it's nice and easy to remember. It's actually just going to be the first step of step 3. So remember, when we cut B in half, that's what goes in that box. Okay, so in here, that is going to be half of B. Okay, so now I am going to, so remember that B is negative, so this should actually change into a minus. So it's going to be minus 2.5. Okay, so I just want to say, supposedly, right, squaring something means multiplying it by itself, right? So that's the same thing as x minus 2.5 times itself. Now, I'm not going to show you here, but what's really cool is when you do the distributive property or foiling, whatever method you do, surprise, surprise, you're going to end up with that perfect square trinomial again. So we're not just doing random stuff. We're actually doing things that work. Okay, so Again, you don't have to. So if you were to do it backwards, right, you could use the AC method, but you don't have to do all that work, right? So that's why there's like a template or a recipe, if you will, of completing the square that takes care of it for you. Okay, so you're just going to have to memorize the steps. So now what we have done is we have converted it from standard form to something that looks like this. Okay, so now we are so much closer to getting x by itself. So step number 5, and that's the last step, is we're going to solve using the square root method. Why is it called the square root method? Well, duh, because you're going to take the square root of both sides. Why are we going to do that? Because the opposite of squaring is square rooting, right? So when you take the square root, these that squared goes away. And what is left is what's inside the parentheses. So we have x minus 2.5. Here's the thing, though, that you have to be super careful, okay? It's such a common mistake. Whenever you solve for x and you take the square root, always, 100% of the time, you always have to have a plus or a minus sign, okay? So underneath step 5, I'll write plus or minus. You always do this, okay? So now, remember the direction says you can round to the nearest tenth. So I'm going to drop down that plus or minus sign. We'll talk about what that means. And you're just going to take the square root of 3.25 on your calculator, round it to the nearest tenth. That's going to be about 1.8. Okay, so now we are one step away, right? If we combine like terms. Now, before I do that, you can in this step, right, add 2.5 to both sides. I like to, at this point in time, remind my students, what the heck is that even saying? Well, this is saying two things, that x minus 2.5 is equal to the positive 1.8, or, you guessed it, x minus 2.5 is equal to negative 1.8. That's literally what that previous step is saying. So I like to do the split first, and then from there, right? So you were solving two completely separate equations, right? With the same steps though, right? Because we should be adding 2.5 to both sides for both of these equations. So the left side, you're doing positive 1.8 plus 2.5, and you should be getting 4.3. That's one of the solutions. And on the other side, when you add 2.5 to both sides, that's going to produce the other answer. So that is going to be 0.7. All right, so what happens when you have an x stuck inside of a log, right? I can't just, like, for example, subtract 9 on both sides. It's inside the log. So how do we break that 7x plus 9 outside of the log? Well, just like you solve any equation, you have to do opposite operations, right? Opposite of squaring is square rooting, and vice versa. Opposite of addition is subtracting, multiplication, division. So what's the opposite of log? Exponents, okay? So they go hand in hand. Okay, so as you can see here, there is no base. Now, there is a base, actually, it's just imaginary. When you do not see a base, it's understood in math that it's always going to be base 10, okay? So how do you convert it to exponential? I like to kind of think of it as a circle. That's going to be the little number to that power is equal to the inside of the log, right? So this is the same thing as saying 10 to the second power is equal to 7x plus 9. Now, if you blank out on what should be, you know, what should go where, I do just want to remind you, this 10 is called the base of the log. It should match, this is called the base of the exponent. Base of the log should match the base of the exponent, okay? So that should always be true. So now that you've converted it to an exponential, it's super easy after that, right? So if we simplify, 10 squared is 100, right? So you should simplify first, and then look how easy it looks out. It turns out, right? So now we're going to subtract 9 on both sides. 100 minus 9 is going to give us 91, is equal to 7 times x. And then opposite of multiplying is dividing. Okay, so a lot of the times in Algebra 2, we like to leave things as improper fractions, don't you dare turn it into a mixed number. Or if your teacher asks you to round to the nearest tenth or whatever, that's fine. All right, so what happens if you have x in the exponent, right? I can't divide both sides by 2. That's what a lot of people do. Dividing both sides by 2 is if you have 2 times x, right? Then the opposite of multiplication is division. But again, what's the opposite of exponents? Log, right? They go hand in hand. So in this case, you're going to have to convert it to a logarithmic expression. So remember we talked about the log of the base, the base of the log has to match the base of the exponent. So that should be your first sign, right? So the base is that little number. They should match, okay? And so this turns up being log base 2 of 6. You don't have to put 6 in parentheses. I just like to, equals x, okay? And you could do a little check, right? It should end up being like that little circle, right? This to this power equals 6. So let's say you put x inside the log, right? You could just do a check afterwards just to make sure that it works out. All right, so now, hey, look at that. We already solved for x. So if your teacher asks you to put it in the exact form, you're done. X is exactly log base 2 of 6, okay? But let's say he or she asks you to round to the nearest tenth. You just pop that in your calculator, and that's it. So this first one is specifically through substitution. Why is it called substitution? Because you're literally taking one equation and you're plugging it into the other. Question is, which one do we plug in and where? I like to remind my students, always look for the one with the coefficient of 1. So in other words, we're looking for the number in front of a variable to be 1. That's usually the easiest one because we don't end up getting any fractions. So we want to solve for that, right? Another way, by the way, people might recognize, oh, hey, if we look at this bottom equation, these are all actually divisible by 2. So you can actually, if you went that route and divided everything by 2, right? You end up with x minus y equals 3. And actually, right, so this coefficient here, that is positive 1. So that might be something that you can solve as well. But a lot of the times people don't really realize that. So, and by the way, what if the coefficient of neither of the terms is positive 1? That's when, I don't know if you're in honors or something, you might end up with fractions, but I'm not doing an example like that here. Okay, so what we're going to do is I'm just going to rewrite that top equation. So again, it's always easiest to solve for the variables that have coefficient of 1. So there's an imaginary plus sign in front of there, right? So the opposite of adding 4x is subtracting 4x. And these are not like terms. So you just end up with y is equal to 2 minus 4x. Done, right? You see how when you solve for the ones that have coefficients of positive 1, look, there's no fractions. It's just a simple adding or subtracting on both sides, right? So now that was the top equation. So we are going to substitute the top into the bottom equation. So sometimes you get scenarios where you're going to take the bottom one and plug it into the top. It just depends, right? So now that we know what y equals, we don't know the exact value, but at least we know it's equal to 2 minus 4x. We're going to plug that in there, okay? So I'm going to copy down that bottom equation, right? And remember now, we are just going to be plugging in this in that spot. So a common mistake is people do not substitute with parentheses. Anytime you substitute in any situation, you should always get into a habit of always substituting with parentheses, okay? Because what you should end up doing is you should end up using the distributive property, okay? So now if we distribute there, right? And actually, let me just copy down the 2x. A negative times a positive, so that should end up being minus 4, and then a negative times a negative, so that should be a positive 8x. Okay, and now this just turns into a regular multi-step linear equation. I would recommend to always make sure you combine all the like terms on each side of the equation before moving stuff on either side, right? So 2x plus 8x, that's going to be 10x. Drop down the minus 4 equals 6, right? Now we can combine like terms, moving them across the equal sign, right? So we end up getting 6 plus 4 equals 10. And then the opposite of multiplying by 10 is dividing by 10. So we end up with x equals 1. So whenever you're solving a system of linear equation, your final answer should always be an ordered pair, right? Because later when we graph, we should see it's going to be that intersection point. So how do you find the married y value? You just plug it in. Now, does it matter whether I plug in x equals 1 in here or in here? No, because it's going to be a solution to both. So I usually tell people, why don't you plug it into the one that looks the least annoying, in which case both of them look kind of equally as annoying. So I'm just going to now plug, I'll choose the top one, right? So I'm just going to rewrite that top equation. So we found out that x equals 1, right? So I'm just going to now take this and plug it in there, right? So now we have 4 times 1 plus y equals 2. What comes next? How about you simplify first? 4 times 1 is 4 plus y equals 2. Last but not least, we can just subtract 4 on both sides and end up getting -2 for y. And a lot of times people just stop there, but don't forget, your teacher is looking for your an ordered pair as an answer. So it's always x comma y. So it should end up being 1, -2 as your final answer. So now we're going to confirm, we're going to get the same answer, but using a different method, okay? So depending on what teacher you have or what textbook you're using or whatever, the elimination method can also be called the addition method because you're going to be adding them together and we're looking for something to eliminate or cancel. Or you might hear the fancier version, it's also called linear combination method, okay? Because you're going to be, when you add them together, you're combining them. So very first step is you can just add them together and see if anything cancels, right? 4x plus 2x, nope, that's 6x. Y plus -2y, nope, that's -y, right? So if we add them together to start, nothing cancels. So what if you have a scenario where nothing cancels right off the bat? You are looking to multiply something, okay? Now, question is, what do you multiply and where do you do that? So there's many different ways you could do this. If you would like to cancel out the x's, right, you're looking to match the numbers and you're looking for them to be opposite signs, right? Because opposites cancel. So if you want to get rid of the x's, right, you're going to have to multiply the entire bottom equation by -2, right? Because -2 times +2 is -4, which is the opposite of +4. If you want to get rid of the y's, right, so we're looking over here, they are already opposite signs. So all you have to do is just multiply the top equation by +2, right? Because 2 times y is 2y. And down here we have -2y, right? So we have to get the coefficients to match the numbers in front, and we want to get them to have opposite signs. So again, does it matter what we do first? No. So maybe, I don't know, I'll just get rid of the x's, right? We talked about that we're going to distribute the -2. Now, a very common mistake is that people do a good job. They distribute only to one side of the equal sign. Please don't forget to multiply it to everything, or else you're actually changing the problem, right? So if we want to stay organized, we're not touching that top equation. So I'm just going to be copying that down, right? We didn't do anything to that. This one, however, is going to be changing, right? We're not changing the value. We're just distributing the same number to everything. So we're not actually changing the value, right? So we end up getting, so that would be a negative times a negative. So that would be positive. And then -2 times 6 is going to give us -12. Okay, so now when we add them together, opposites cancel, right? And so adding all the like terms, 1y plus 4y equals +5y. And then 2 plus -12 is -10. And then we're going to be dividing both sides by 5. So y is equal to -2. Now, does that match the y value when we did this one? It sure does, right? So we know we did it correct. Now, pretend we didn't know what the answer was, right? We already know that the x value is 1, but if you were to do this, you have to show all the work, right? So again, does it matter whether we're going to plug in -2 in this y or in this y? No, right? Because it's a solution to both. So probably the easier one, you might disagree, I don't know, but it looks like I'll just plug it into the top again, right? And so now we're going to take the -2 and plug it into the y spot. So that's going to be 4x plus -2, or you can just write -2. And then the opposite of subtracting is adding. So we get 4x is equal to 4. And would you look at that? Surprise, surprise. When we divide both sides by 4, we do get x equals 1. So we do have a confirmation of the same answer in this case. So now we're going to confirm using graphing. So when you graph, first of all, please make sure it's in y equals mx plus b form, right? This is called slope-intercept form. Why is it called slope-intercept form? Duh, so that way you can identify the slope, which is the coefficient or the number in front of the x, and you can identify the y-intercept, aka that point that intersects the y-axis. The y-intercept is always that starting point, right? Because that's the point we know that's on the graph. And then from that spot, then the slope tells us the direction. Where do we go? Do we go up and left or down and right, you know? So I'll talk about the slope in a second. First task we have to do is convert both of them to y equals mx plus b form, right? Because both of them are in standard form. So we actually already did, we already converted that top one in part A, but I'll show it again. Let's see here. So, yep, I'll just do it over here. So 4x plus y equals 2. Okay, so again, in my course, which I'll leave a link below, I go through everything in detail with lessons and homework and quizzes and all that. So in the meantime, I will just show all the steps, not, you know, spending forever on each problem, or else this will literally be a 10-hour video, right? So we already did this in part A. You're going to subtract. Now, could you also rearrange them and write -4x plus 2, which that's technically in y equals mx plus b form? Yeah. Do you have to do that? No, right? Because just make sure that the m value is going to be the coefficient of the x term. So I like to write m equals b equals, right? So the coefficient is -4, and the b value is 2. So when you have a whole number for slope, when we graph, you always want to put it over 1 because that 1 tells us really important information, okay? So again, put it over 1 if you have a whole number. So now, what does this tell us? So first of all, when we graph, our starting point is at the positive, right? It's on the x-axis, but it's at +2. So I'm going to put, right, that's 2 units up. So now, what is this -4/1 saying? So let me actually go back over here, right? When we talked about slope, a lot of you know it as rise over run, right? And rising, you would think of the vertical or the y direction. Running, right? You don't run up or down, you run side to side. That's going to be the x-axis. So because -4, right? So I'll just write this over here. We have -4/1. Because the negative is assigned to the y value and y is up and down, negative means it goes down, right? And then because the 1 is positive, that's left or right. And because positive x, that's going in the right direction, that's going to be down and right. Now, let me just back up for a second because a lot of people tend to be confused about something. Could have I assigned the negative on the bottom? Yes, because a negative divided by a positive is a negative, and also a positive divided by a negative is also a negative. So in this particular case, you're actually going up because it's positive and left because the x is negative. Now, up and left is the same thing as going down and right. So you'll end up getting the same line. And then last but not least, that people also can get confused over is what happens if you have a negative on the scooted right to the side. So all of these three scenarios are saying the exact same thing. So when you see a negative on the side, just pick one. You can either assign the negative to the top or you can assign it to the bottom, okay? Either way, you're going to get the same answer for everything. So I just wanted to take the time to talk about that real quick because that tends to be what people get confused about. Okay, so now from that spot, as I said, we're going to go down 4 units, 1, 2, 3, 4, and then to the right 1. Now you only need 2 points to make a line, so you can use your ruler and you can, connect that line. But since we're looking for an exact intersection point, a lot of people like to actually just follow the pattern so that we can see exactly which point it intersects. So again, we also talked about it's the same thing as going up and left, right? Up 1, 2, 3, 4 to the left. So I'm going to do the best I can to draw a very squiggly line. All right, so that's the top right, the top line. So now I'm going to take the bottom line, and we're going to solve for y in this case. So I'm just going to copy that down. So 2x minus 2y equals 6. So we're trying to get the y by itself. There's an imaginary plus in front of there, so we're going to be subtracting on both sides. Those are not like terms. Be super careful. You should bring down that negative, okay? So again, as I said, those are not like terms, so that's just 6 minus 2x. And then just be super careful. You're dividing by -2, but for everybody, okay? Whenever you multiply and divide stuff, you have to do it to everybody, right? So now we end up getting y is equal to -3. And then that says a negative divided by a negative, which is a positive, right? And then the 2's cancel. So, or if you wanted to rewrite it, that's the same thing as positive x minus 3, right? You could do it either way. So again, I would make sure to write m equals b equals, right? You should at least get credit for identifying that. So again, the m is always the coefficient of the x term. So whichever equation you're looking at, as we can see, you should end up getting +1. People write x, that makes no sense, right? Don't include the x as the slope. And then b is, be careful, a -3. And we talked about before, when you have a whole number for a slope, we actually love fractions, right? So you want to always put it over 1. So the b value is our quote unquote starting point. So on the y-axis, you're going to start at -3. And then the slope, both of them are positive, right? So remember, the y value is either up or down. Because it's positive, it's up. And then the x is either left or right. So if it's positive, it's right. If it's negative, it would have been going left, right? So we're just going to keep going up 1 to the right 1. And as you notice, you can see they already intersect at that point. But a lot of people like to kind of just finish the pattern as much as possible, but you don't really have to go beyond that step because we are looking for the intersection point, which we already found as 1, -2. Does that look familiar? It sure does, because we found that algebraically in steps A and B. So the degree is just a fancy word for what is the highest exponent. That's all it's asking for. So notice it's not in standard form. In other words, it doesn't start with the highest exponent and then go in descending order. They're all scrambled. So just make sure, right, you're looking for that highest exponent. In this particular case, it's 4. Now, the leading coefficient actually goes hand in hand. It's specifically the coefficient of the term with the highest exponent. So in this particular case, careful, it's a -6. The constant is the number with no x attached to it. In this case, it's going to be a +1. A term is something that, plain and simple, you can recognize how many terms there are by circling the minus and plus signs, only the minus and plus signs, and you can see they make a partition, right? There's one, there's another, there's another, and there's another. So there's 4 terms. A term is, simply put, it's just something that's glued together by multiplication, right? So there's 4 of them. Is this a monomial? In other words, that means 1 term, binomial, 2 terms, trinomial, that's 3 terms, or neither. Well, given that this is 4 terms, that is going to be neither. So we would just call this a degree 4 polynomial. So now we're going to square this binomial, right? There's 2 terms and we're going to square it. And a very common mistake is people will say, oh, look, I'm going to square the 2x and I'm going to square the 3. Unfortunately, you're going to get most of the correct answer, but not the full picture here. So what you first have to do is put it in what's called standard form. Doesn't squaring something mean multiplying by itself twice, right? So now you actually should be doing the distributive property or foiling. I personally use the distributive property, if I can speak today, hello. Or if you want to use the FOIL method, go right ahead. So I just distribute the 2x first, and then I distribute the 3 next, right? So 2x times 2x is 4x squared. Remember, we're adding the exponents there, and the imaginary exponents there are 1. And then 2x times 3 is just going to be 6x, right? Now we're going to distribute the positive 3. 3 times 2x is another 6x, and then positive times a positive, so that's going to be positive 9. Okay, and then last but not least is you're going to combine those like terms. 6x plus 6x is 12x. Okay, so there is going to be that middle term that people will miss out on if you just square these 2 terms. So be super careful on that. I can't even tell you how many times I see that common mistake. Okay, so now it's time to multiply this trinomial times that binomial. So again, I'm not sure the way when you do it in class. I personally just distribute everything. Okay, so first I will, and you could look at that second parentheses and first distribute the x. There's so many different ways you can do it. I usually just read from left to right. So I guess I can just distribute the 2x squared to everybody in that second parentheses, right? So 2x squared times that says x to the first. Remember, we're adding the exponents together, so that's 2x to the third. A positive times a negative, so that should be minus 2x squared. Now it's time that we're going to distribute the negative 6x. So negative 6x times positive 6x, so that's minus 6x squared. A negative times a negative, so that should be positive 6x. And again, if you're doing this a little differently, you're going to get the same answer as me. It's just going to be in different orders. Okay, so now we're going to distribute the positive 3. So that would be 3x. And then a positive times a negative, so that's going to be minus 3. So now we're going to look to combine like terms. So remember, like terms only are the ones that have the same exact exponent. So these 2 have the same exponent and these 2 have the same exponent. So I am going to copy down the 2x to the third. Now, when you add and subtract like terms, you leave the exponent alone. You only combine the coefficients. So negative 2 minus 6, that's going to be minus 8. Leave it as x squared. The only time when the exponents change is when you are multiplying and dividing terms. Adding and subtracting, you keep the exponents the same. So that is going to be 9x. That stays to the first power. And that is the final answer. So again, if you got it in scrambled order, right? As long as you keep the positive terms positive and the negative terms negative, you can write it in any way. I personally like to do things in standard form, which just means you start with the highest exponent and you go down in descending order. So dividing polynomials is a totally separate thing. You're going to need long division, and you can use synthetic division in this case. I can show you later. I know that you can use synthetic division because the catch is that what you're dividing by has to be to the first power. The degree has to be 1, or in other words, it has to be linear, right? So I'll show you how to use synthetic division later. But for right now, we can focus on long division. So first things first, we do have to know a little bit of vocab. Now, what is being divided is called the dividend, and what you are dividing by is called the divisor. So for long division, the symbol is going to be this way, right? Synthetic division, which I'll show later, is going to be the flip of that. So you're always going to put the divisor, what you're dividing by, on the outside, and the dividend is always on the inside, right? What's being divided. So I'll write the steps on the right side here. So in my own words, I would say that the very first step is that you're trying to match. What are we trying to match exactly? The variable terms only, okay? And you're looking to match the variable terms with the highest exponent. So in this particular case, we're looking to match x, right? And 2x squared. So you're looking to multiply something, right? So you have to ask yourself, x times what gets me to 2x squared, right? Because we're trying to match them together. So I need a 2, and remember product rule says that the exponents have to add up together, right? So those exponents are both 1, 1 plus 1 is 2. So after you have matched those terms, now it's time you're going to multiply. You're going to multiply whatever you've matched, so that 2x at the top, by the entire divisor, okay? Now remember, the divisor is a binomial, so please don't forget you should be always doing the distributive property, right? So we're looking to distribute the 2x to the x and to the -1, right? As I said before, you're multiplying it by the entire divisor. So 2x times x is 2x squared, right? We needed to match them, so that makes sense. And then 2x times -1 is going to give me a minus 2x. So why are we trying to match? Is because the next step is to subtract, right? And so when you are subtracting the same terms, it cancels out. So that is why we're trying to match in the first place. Now, I usually like to write a minus on the outside because a very common mistake is people forget to subtract the second set of terms. So 2x squared minus itself is 0, right? Now, here's what people technically, there's a subtraction here, right? So people accidentally do -6x minus 2x, which is a -8x, right? That is actually saying -6x minus the -2x. So whenever you have two minuses next to each other, it actually turns into a plus. So you should actually be looking to do -6x plus 2x. That is going to be a -4x. And then you're just going to drop down that +3. And you're just going to rinse and repeat, right? So you're going to do it over and over again until you can't do it anymore. How do we know and how do we know when to stop? I'll talk about that in a second, right? So now we're going to go right back to the top and we're looking to match again. We're looking to match the variable terms only. So we're going to see x times what gets me to -4x. Well, I just need a -4, right? So we matched it. Now we're going to multiply. But again, just be careful. You're always going to be multiplying by the entire divisor. And so you should distribute. So -4 times x is a -4x, and then negative times a negative, so that should be +4, right? So again, then after that, the next step is to subtract. So you're subtracting both terms. So -4x minus -4x is the same thing as -4x plus 4x, so that cancels. That's the whole point of matching. And then be careful, that says 3 minus 4, which is a -1. So you have to ask yourself, can I go one more round here? And the answer is no, because now you're asking yourself, can I multiply or can I match? Can I do x times anything to get to -1? And the answer is no. Okay, and so the rule of thumb is actually when you get one exponent less than the divisor, that's when you know you're done, right? So this is to the first power here, and this is like saying x to the 0 power here. So when you end up getting one less than the exponent, you know you're done. So that's another way you know you're done. So I personally like to circle that last number because that tells me that this is going to be the remainder. Okay, so it's not like in middle school where you just get to write R1, which means remainder 1. So the final answer is going to be, let's see if I can make it in, I don't know, orange. All right, so the final answer is going to be 2x minus 4, but then you're going to add it with the remainder, but here's the catch, you have to put the remainder over the divisor. What do I mean by that? Right, so our final answer is going to be 2x minus 4 plus the remainder, as I said, and you're going to put that remainder over the divisor. Remember, the divisor was x minus 1. Okay, so if you want me to write out everything, right? So the final answer is going to be, the quote unquote answer, right? The result that we get when we do the division is called the quotient, right? So 2x minus 4 is called the quotient. So you're going to do in general now the quotient plus the remainder, what's left over the divisor, right? So that is how we write the final term or the final answer. Now let's go over synthetic division. So as I said, synthetic division, you can only use it when you have a linear divisor. In other words, the highest exponent has to be 1, as I talked about before. This is going to be the opposite or the flip symbol than the long division symbol, and leave a little bit of space because we're going to be writing numbers into 2 rows there. So the very first step is you want to set the divisor, right? So I guess I'll just write the whole thing. You want to set the divisor equal to 0 and then solve for x. Okay, so essentially this is the root or the x-intercept of the dividend polynomial. So if we do that in this particular case, right, we're going to add 1 to both sides. And so we get x equals 1, right? So in the future, when you learn what's called rational roots theorem, you're going to find that this is the root of the dividend. And so then you would then just plug that into the synthetic division. So it's all connected. But anyway, then what you're going to do is you're going to, this number over here goes always on the outside. So you're just going to copy it. And then what you're going to do, so we're not even doing synthetic division yet. This is all going to be a setup. Okay, so number 2 is then you're going to, very importantly, you're going to take the coefficients of the dividend. Very importantly, it has to be in descending order of the exponents. Okay, so if you didn't write it in a particular order, it's wrong. Okay, it's a very specific order. What do I mean by descending? In other words, you're going to, right? So it's already in descending order. The exponent goes 2, and then it goes 1, and then this is like saying x to the 0. Okay, so you're taking the coefficients, so the number in front of the variables. So be careful, that should be -6 and then +3. Now, just to be super careful, by the way, totally changing the problem, just bear with me for a second. Let's say that this was the dividend. In other words, that -6x was gone. Then super important, right? This is like saying 2x squared plus 0x plus 3. So you would have to put a 0 placeholder. I can't stress that enough. So it does have to be in descending order, okay? So if it like skips an exponent, you do have to put that 0 placeholder or else it's wrong, okay? And then we're still not ready to start. The very last thing you have to do before you actually do synthetic division is you're going to drop the that leading coefficient, that first number, down. All right, so in this particular case, that leading coefficient is 2, so we're going to drop that down. So now we fully set up what we need to do. So here are the steps. It's very similar to long division in that you're going to multiply. You're going to multiply all these numbers down here, always times the divisor, okay? Now, if we notice, by the way, let me back up, there's no variables when you deal with synthetic division, which is really nice. So you don't have to worry about doing like a lot of the common errors in long division. That's why a lot of people like synthetic division, okay? So you're only working with numbers. So let me actually just write that in the list. Okay, so we're going to actually start the synthetic division. I'm abbreviating here. Here are the actual steps. Okay, so you're going to multiply by the number on the outside. And then instead of subtracting like you're doing in long division, you're actually going to be adding down. Okay, so that is the formula. So 2 times 1 is 2, and then add down, and we should get -4. These numbers should look familiar, but if not, that's fine, right? And then we always multiply by that outside number. So -4 times 1 is -4, and then add down 3 plus -4 is -1. Always circle the last number because that last number is the remainder, which should look familiar, right? We got the -1 remainder in long division. So now once you are done, question is, how do we actually read these numbers on the bottom? So there's a very specific way. So these are actually going to be the coefficients of the answer. Okay, so this is, or should I say, of the final answer. Here's the catch though, that 2, right? So this is the coefficient of the answer, but you always do it the exponent is 1 less than the degree of the dividend. What did I just say? Okay, so in other words, since the degree or the highest exponent of the dividend was 2, so this is going to be to the first power. It's 1 less, and it goes in descending order. So then -4, right? In descending order, this would technically be x to the 0 power, which is 1. So you don't ever need that, right? And then once you are done, you've reached that 0 exponent, right? Like I was talking about here. Then you're going to put that remainder over the divisor, right? So plus the remainder over, remember the divisor was x minus 1. So we do get the same answer. So I'll write down over here, right? So I guess I'll just add a note. So this is to the first power because this is 1 less than the degree, which is the highest exponent of the dividend, right? What you're dividing by. All right, number 13. So is this a function or not? In simple terms, it's a function only if there's no repeated x values. So all the x values are 2, -1, -2, and 5. Since there's no repeated x values, it's a function, okay? And your teacher should be giving you credit for that answer. Or in fancy language, it's the set of inputs or x values that has only one output each. Output is the y value. So that's why people just like to say, is there repeated x values or not? So you can just put that as your answer. So now if we have a graph, if you're asked to identify whether it's a function or not, there is a test called the vertical line test. A vertical line is up and down. So the vertical line test says that if the graph hits the vertical line in more than one spot, it's not a function. So if it hits it exactly in one spot, it is a function. So everywhere that I draw a vertical line, it's always hitting it twice. The only time that it's hitting it once is actually at this x value -3, right? However, it has to be true for everywhere. So even though in that spot, x equals -3, it hits it one time, be careful, it has to be the full graph. So this case, the answer would be no. I personally just tell my students to say, because it fails, or in other words, it does not pass the vertical line test, and that should be good enough. Now, right, inverse, the domain and range flip. I just dropped my pen. So as I was saying, the inverse, the domain and range flip. So in other words, what do you think of as the opposite of a vertical line? A horizontal line. So it's similar to the vertical line test, but now you're looking, if I were to draw a horizontal line everywhere, notice that it hits the graph exactly one spot every time. So the inverse is a function because it passes the horizontal line test. Okay, so when you're asked this question, you don't actually have to graph its inverse, which just means that you take every ordered pair, x comma y, and you flip it, right? You will have to, in Algebra 2, know how to graph the inverse, but you don't have to do that here. So now, is the relation called a one-to-one function? The answer is no. So it's a one-to-one function if it passes both the vertical line test, which I will abbreviate it as VLT, and the horizontal line test, I'll call it HLT. So because it does not pass both, I forgot that word, the vertical line test and horizontal line test, it's not one-to-one. Okay, so now we're going to identify the domain and range. So the domain is the set of all x values, and the range is the set of all y values. And depending on your teacher, but most likely you are going to have to use proper notation. If not, well, that's pretty cool. But for the most part, you are going to have to use a proper notation. So D stands for the domain and R stands for range. So the domain is a set of numbers. So you should be using like those little curly mustache brackets. And the range is also a set of numbers. So the domain is the set of x values, as I was saying before, and the range is the set of y values, as I said before. And then in math language, because math is a language, just like learning any other language, you're going to put that vertical line there. And this vertical line in math language literally means such that. So the domain is the set of x values that are such that. Now here's the catch. You cannot list the ordered pairs because there's infinite. So how do we describe, right, the set of all x values? So what are all of these x values? So the x values is this number line here, right? That's the x-axis. So if you look, there is nothing on that side, right? All of the points exists to the right of that x value. That x value is -3. So in math, how do we say all the x values to the right of -3 on the number line? We say those are all the x values bigger than -3, right? -2, 0, 17, 20, I'm just picking any random numbers. Those are all on the right side of -3. So we write that x is greater than or equal to, because there's an imaginary closed circle. It's understood. If there was an open circle, then you would not put the underline, but you would always put the underline there. So now the range is the set of y values such that, so now the y-axis is over here. So you're asking yourself, is there a spot where it's blank, the graph is blank? And the answer is nowhere. It exists everywhere, in other words. And it's because of these arrows here. It goes on forever and ever. So all of these y values are going to be existing. They're going to be used up. So you can just write all real numbers. Why do we write all real numbers? That's kind of weird. Like, are there imaginary numbers? Yes, there are. So now we're going to look at the y-intercepts and the x-intercepts. So the question is, how many y-intercepts are there? There's going to be 2 of them because they are the points that intersect the y-axis. So those ordered pairs are 0, 5 and 0, -5. And the x-intercepts, in this particular case, there's only going to be 1 of them. And that is going to be the ordered pair that intersects the x-axis, which is -3, 0. So now we're given 2 functions. We'll call the top one the f function and the g function on the bottom. So again, math is a language. First of all, this does not say f times 2. This says f of 2. And what the heck does that mean in math language? That's fancy for just asking you, what is the y value when x is -2? So in other words, when you see these types of problems, they're substitution problems. Okay, so again, I go through all this in detail in my course, which I left in the description below. So where do I plug in the x? Do I plug it in here or into here? Well, that's what this tells us. It wants us only to plug it into the f function. So here's the f function, right? And so it wants us to plug in 2 in the x spot. So always get into a habit of putting parentheses around what you are substituting. Because, for example, if you are asked to plug in -2, right, you better put -2 in parentheses on your calculator, because -2 parentheses squares is +4, and -2 squared without the parentheses is -4. So again, I just like to say over and over again to people, simplify or substitute rather with parentheses. Okay, so if you're using PEMDAS, that's exponent first. So that y value is 6. And what's the connection, by the way, right? The answer to f of 2 is 6, but I do just want to add what this is saying, if I put these together, is that when x equals 2, y equals 6. So that just told us important information, that if you put them together, x comma y, that ordered pair 2 comma 6 is in the f function. Okay, but again, the answer is 6, because it's asking us what's the y value specifically, not what ordered pairs on the graph. So now it wants us to, this is saying you're going to plug in x equals 1 now into the g function. That's what that is saying. Okay, so now be super careful. When you make a substitution, you're always, I tell people to hug parentheses around the x. Okay, so the +1 is going to be going in that spot. So if you notice, the parentheses is going, so the negative sign is going to be outside of the parentheses. So this is a big deal, because the difference is there's like an imaginary -1 here. There's like an imaginary multiplication going on. That's saying -1 times 1. So that's actually -1. And then drop down the +1. So the answer here is 0. That y value is 0. This is totally different of what the heck is this saying? This is saying you're doing substitution 2 times. So you always look at the inside and then work yourself out. So there's like a double parentheses going on. So if I kind of emphasize these pair of parentheses here, we can see that the f of x is inside. So again, you always work inside and you work your way out. So this is going to be substitution twice. First, you're going to make the substitution. You're going to plug in f of x. Do we know what f of x is? Yes, that is going to be x squared plus 2. So stay organized. We're not touching this g of, right? So the first substitution is, we know what f of x is. That's x squared plus 2. So that's substitution number 1. Substitution number 2 is now, remember, just like before with the numbers, this is saying to plug in x squared plus 2, right, in the x spot. Where? In the g function. Okay, so now instead of plugging in numbers like before, we plugged in 1 in the last example, now in the x spot, we're plugging in an entire expression. So remember that the g function, I'll just write it down, right? The g function was -x plus 1. So now we're going to plug in x squared plus 2 in the x spot. And remember, as I said before, you're going to plug it in to the, you're going to hug the parentheses around the x. So there should be a negative symbol, or a negative, yeah, there should be a negative outside of the parentheses is what I'm failing to say, right? So we put the x squared plus 2 in that spot, and then this plus 1 here, just bring that down. So we made that second substitution. We plug in x squared plus 1 in this spot. And now it's time for PEMDAS again in order to simplify. We always multiply before we add. There's an imaginary times -1 here. So you're looking to distribute the -1. So that's going to be -x squared, and then a negative times a positive. So that should be -1. and then drop down this +1. And then now it's time to combine like terms. The only like terms are going to be those whole numbers, but -1 + 1 is 0, so that cancels. So actually, the answer is -x². So I just want to note here, like let's say when we looked at part B, notice when you plug in a number, your answer is a number. When you plug in an expression, right, your answer is going to be an expression. So if you plug in something with x's, your answer has x's in it. If you plug in a number, your answer is just a number. So it makes sense that our final answer does have x's in it. You did it totally correct. So what we did was we plugged in one function, so the f function, inside the g function. And this is called composition. Again, I go through all this in detail in my course. So now we have this, again, math is a language. I hate this notation, I'll be really honest with you, because people get confused. You're not raising anything to the -1 power. This is not property of exponents. This is saying find the inverse function. I know that's confusing. I hate that notation. Okay, so that -1 actually means find the inverse. Which one are we finding the inverse of? The f function, right? So if it told you to do this, now it's asking you to find the inverse of the g function. Okay, so this is just the definition of an inverse function is that the domain and the range flip. So in other words, right, the x's and the y values flip. So this is true if you take a graph and you flip all the ordered pairs of x and y. This is also going to be true in the equation. So your very first step is you're going to be writing down the function of f, which was x² + 2. And then you're going to flip the x and the y values. I don't see a y anywhere. Well, you have to know that y is the same thing as f of x. So you're going to erase f of x, and by definition, that's actually the y value, right? So that's the function, y = x² + 2. Now it's time that you're going to make the flip. So in the y spot, you're going to put an x, and then the x spot, you're going to put a y. So it's going to look like x is equal to y² + 2. So now what's left to do after you make that switch is to now solve for y, okay? So remember, we always like to write equations as y equals. So the question is, how do you solve for y? So first of all, let's see, plug this, write this up here. Okay, so what's stopping the y from being by itself? Well, it's being squared, and then it's also being added to 2. So first you have to take care of the addition subtraction, right? So it's being added by 2, so we want to subtract 2 on both sides. So that says x - 2, those are not like terms. We're going to just leave that as x - 2 = y². And then we have to get rid of that squared. How do we do that? Well, the opposite of squaring is square rooting. So we're going to, again, right, make sure you square root both sides. So the squared goes away. And remember, when actually you take the square root of something, when you're solving for x, it's actually technically going to be a plus or minus. That's always true. When you take the square root, it's plus or minus. So the question is your answer going to be plus or minus the square root of x - 2? The answer is no. If you were to graph that, it wouldn't be a function, right? Because remember, the definition of a function on the graph is it has to pass the vertical line test. If you were to graph this, this would be a parabola or a U-shape drawn sideways, right? So again, it would fail the vertical line test because it hits it in more than one spot. So you don't have to remember all of this. So the answer is just either the positive or the negative of that. So one correct answer would be y is equal to the positive square root of x - 2. Or if you put y is equal to the negative square root of x - 2, that is another correct answer. But typically in math, we like to actually, we like positive stuff. So you could just leave it as the positive square root. The very last thing that we should do, or that you should do, is you cannot leave it, or I don't know, your teacher should not really accept y equals, right? Because this is what y equals. They can't be the same thing. X squared plus 2 is not the exact same thing as square root of x minus 2. So they can't both be y. So remember, if I were to put this back, this was f of x, right? So what is this function? This function, it was the inverse of f. Okay, so that is how you write the final answer. So instead of y, right, this is what we're trying to find. So just make that substitution back. So let's write an exponential model for buying a coin for $110. And then every year, which is x, the value of the coin, which is y, increases by 4%. So just to let you know, R is going to stand for rate. R is always in percentage, but we are going to put that value on the calculator, and there is no percent symbol on the calculator. So you can't just use 4 as the R value. What you have to do is move the decimal place to the left 2 times, right? Because 4% means it's out of 100. So you're dividing by 100, you move the decimal place. So be super careful. The other thing is that the keyword says that it is increasing, and that tells us that it's going to be an exponential growth. And so that is going to be the equation on the left because you're adding the rate. If it was decreasing by 4%, then it would have been the decay or the decreasing model. So all you have to do is just write a model. So A is going to be the initial amount. That stands for A, which is 110, right? So I'm going to write 110 times 1 plus R, which is the rate, but be careful moving the decimal place to the left twice. And then X stands for time. So we're just going to leave that as a very general equation. Now we're going to use that equation to predict, right? That's what equations do. What is the value of the coin in 5 years? So you just have to know, where do I plug in 5? Do I plug it in for X or do I plug it in for Y? Well, since it says in the problem that X is time in years, that means we're just going to substitute it in the value for X, right? So it should look like that. Now, the beauty of the TI-83 or TI-84 calculator is you could just pop it in all in one shot, 110 parentheses, yada, yada. Or you can do PEMDAS, right? So you should be looking to add those together and then raise it to the 5th power and then take that answer and multiply by 110. So you should end up getting about $133.83. Now, when you do these problems, it's super important to always just check for logic, right? So if the value increased and you started with 110, you should look to have an answer that's bigger than 110. So let's say you got an answer after 5 years and you got it smaller, then that means that you used the wrong model. So now let's do a linear model. So the functional relationship, it says the cost of heating your apartment, right? C for cost, and the outside temperature, T stands for degrees in Fahrenheit. So it gives us this linear model here. We know it's linear because the independent variable T is raised to the 1st power here, right? So what is the cost of heating your apartment when it is 30 degrees outside? It's just asking you, where should I plug in 30 degrees? Should I plug it in for C, which is on the outside? C of T, that just means that the cost is a function of the temperature, right? But that would be C. Or am I plugging it in for T? Well, if you read carefully, degrees, right? It tells us it's going to be T. So you are just plugging in 30 in the T spot. So if I plug it in, right, if I substitute it, where I see a T, I'm going to put 30. So that's going to look like C of 30, which just means a substitution. I'm going to multiply negative 2.8 times 30 degrees. And then I'm going to take that answer and add it to 209. And so that cost is going to be $125. Part B is very similar to Part A, except now we are substituting 65 into the function. So that's negative 2.8 times 65. Do that multiplication first and then add it to 209. So we do get $27. And you should always check to make sure that logic after you're doing word problems is correct. The fact that it is hotter outside, does it make sense that I'm going to pay less, right, for the heat? Absolutely. So now this is a little different. Now this is asking for the temperature, right? So this is saying now instead of solving for T, I'm sorry, you're solving for C, now you're solving for T. So it tells us the C, okay? So it tells us that you paid $181 and now you're solving for T, right? So I'm going to now put 181 in that spot, copying everything else down. And now, as I said, we're going to solve for T, right? So how do we do that? First, we got to combine like terms. So we're going to subtract 209 on both sides. And then negative 181 minus 209 is negative 28. That is equal to the multiplication, right? So now to get rid of that negative 2.8, I'm going to be dividing by negative 2.8. And a negative divided by a negative is a positive, so I am going to get 10 degrees Fahrenheit. So this is asking for the slope of the function and what does it mean in the problem. So before we do anything, I'm just going to rewrite the function equation here. And people might not really like that C of t. It confuses them, but that just means that the cost is a function of time. And what does that even mean? It means that the cost depends on how hot it is outside, right? Or how cold it is outside. That's all that's saying. So you don't really need that C of t. That's kind of like the f of x, right? So you could just write C. And then if we take it even a step further, you should ask yourself, well, what is the x in the problem and what's the y in the problem, right? So C is going to be the dependent variable. It's going to act like the y. And t is like the x value, right? That's the independent variable. And what that does that people like just identifying which one's the x and which one's the y is that now when we have the y equals mx plus b form, we can clearly see that the slope again is the coefficient of the x term. It's that number in front. And b we'll talk about later is the y-intercept. So we can see here that negative 2.8 is going to be the slope. Okay, so for the first part of the question is asking what is the slope of the function? The slope is negative 2.8. Now, as for identifying what does it mean in the context of the problem, I would always suggest whenever you're working with slope, right? Let's say if we were to graph this problem, we would always prefer fractions for slope, right? So if I were to ask you to graph this function, right, wouldn't you be putting it over 1, right? So if you were to graph it, that would mean it's going down 2.8 units into the right one. But anyway, the reason why it's nice to write it as a fraction is we can see, as I said, which way does it go. So remember that the top is known as the rise, which is the y, and then the bottom is the run, which is the x. So this tells us a lot of information. As I said before, if we were to graph it, since the y value is negative, right? So the y value is either up or down. If the y value is negative, it's going down. And just a reminder, what is the y even talking about? This is talking about cost, right? This is talking about money. So the fact that it's going down, right? So what does it mean? It's decreasing $2.8, right? So with money, we kind of like doing it to the hundredths place. So I could just say it's decreasing by $2.80. When? Well, the x value is positive, right? The x value is either left or right. So again, if I were to graph this, this would be going down 2.8 and then to the right 1. So because it's going to the right, we would think of as increasing, right? If it was negative, it would be decreasing. If it's positive, it's increasing. So what is the x talking about again? This is talking about temperature, so degrees Fahrenheit. So it's decreasing $2.80 for every, maybe we can say degree, for every 1 degree that it's increasing, right? That's one way to say it. Or you can say for every degree increasing, the cost decreases by $2.80. It doesn't really matter the way you word it, but as long as the person who's grading sees the word decreasing with $2.80 and it sees increasing with degrees, that would be enough to get full credit. So now when we're talking about the y-intercept, right? So again, if we write it in y equals mx plus b form, right, it would look like this. And so the b value is going to be positive, right? So this is like the b value. That's the y-intercept, right? So what is the y-intercept of the function? So remember that what is the definition of a y-intercept? It's a point, right? So it's an ordered pair. We're used to, when we're asked this question, just say 209. But notice it says write the ordered pair, because that's also going to help us write what it, or identify what it means in this problem, right? So the y-intercept, that's going to be 0, 209, right? That is the y-intercept as an ordered pair. Now, again, it's really helpful to identify which one's x and which one's y. So since we write an ordered pair as x comma y, that tells us that when the x value is 0, the y value is 209. That's literally what that is saying. And so just a reminder, what is x in this problem? That is the temperature, right? And then the y value is the cost. So that's what you're writing, right? So this is saying that when the temperature is 0 degrees outside, that you are paying the cost for that is going to be $209. So I'll write that out. We are finally reaching the end, my friends. So the last part is actually nice and easy. You just have to memorize. I hate saying that word in math because I like when people have understanding, but you do have to know your parent functions. They're called parent functions because they're just the most basic. And then from there, we can shift them left, right, up, down, and stretch it and shrink it and do all that stuff. So whenever the highest exponent is 2, it's called a parabola. And it's going to be, so a parabola is just that U shape. And again, the parent function, that vertex point, which is just fancy for saying either the maximum or the minimum point, in this case, it's the minimum point, that's going to be at 0, 0. That is different, yet similar to the parent function for the absolute value. Instead of a U shape, it's a V shape. And again, that minimum point is going to be at the origin. So for the square root, it makes sense that the domain, so everything underneath the square root, has to be positive, right? Because otherwise, if you have a negative under the square root, then it becomes imaginary. So actually the domain and the range, right? So the y values, those are all quadrant 1 values. Those have to be positive as well. Because if you take a square root of a positive number, that is also going to be a positive number. And then last but not least, a cubic function, or if the highest exponent or degree is 3, that is going to, I like to say, kind of looks like a sideways S, but upside down. And again, very similar to the other guys, notice those points are all crossing through the origin. So now this is going to go hand in hand when we do transformations. We're going to describe them and then we're going to sketch them without a calculator. So you have to look first and foremost, what's the general shape of your final answer? Well, since it's the absolute value, that's why you have to memorize your parent functions. That's going to be the V, right? So for both A and B, since they have absolute value, those are going to be V, right? If it was squared, it would be a U shape, so on and so forth. So now notice that the +3 on this one is on the outside of the absolute value, as opposed to the +3 here is on the inside. So whenever you have an addition or subtraction on the outside, you're going to always end up going up or down. And whenever you have the addition or subtraction on the inside, you have to memorize that that's always going to be either left or right. So now, when you are going up, it's going to be a plus sign, right? Outside the parentheses. And if it's going down, then you would have minus. So because we see that +3, then yes, it's going to be going up 3 units. If you saw a -3, then it was going to go down 3 units. Now, here's the catch that pretty much more than half of the people make a common mistake. For the inside, it's actually going to be the opposite than when you think. So for left, a lot of people will say, oh, so that means it's a minus sign. Unfortunately, and it's not like people are making this up, it just happens that if you were to go on decimals, for example, or you graph it on the calculator or plot the points, this is just how it behaves naturally. So if you see a plus on the inside, it's actually going left, because a lot of people will want to say right. And then same thing, if it was minus on the inside, you're actually going to the right. So it's opposite than when you think. So since in this case, you see a plus on the inside, again, it's not going to the right 3 units, it's going to the left 3 units. If there was a -3 on the inside, then we would say it's going to the right. So now we know that it's going to be it's going to be a V, because it's the absolute value. And you know you're going to put that point in the center to start, right? So this is, I'm saying comparing to the parent function, right? So this is, if I do the dotted lines, that's what the parent function looks like. So all you have to do is just shift that merging point up 3 units. So 1, 2, and 3. So this is going to be what the transformation looks like, right? So I don't need this anymore. And same thing, same reasoning, instead of it being that center point at the origin, now it's going to be to the left 3 units. So if it was a parabola, right, then you would just draw it like a U shape like that. All right, so now the last question, right? So that's going to be the square root. So again, first of all, you should be asking yourself, what is the general shape going to look like? And so I'll just sketch the parent function here. It would look like this, right? So it's going to kind of look like that little arc going in the right direction. So now in this particular case, so I'll just get rid of that arrow there because it's kind of confusing, right? So notice the difference here is we have a negative on the outside versus a negative on the inside, okay? So when you have a negative and you have it on the outside, both of them are going to be reflections, by the way. But so you have to memorize when it's on the outside, is it going to be a reflection over the x-axis or over the y-axis? So it's always going to be a reflection over the x-axis for outside negatives. And then the inside, you guessed it, it's going to be a reflection over the x-axis, right? So if we compare, if you want, you can draw the regular parent function, right? That's what it would look like. So now what would it look like? Here's the x-axis. It's just going to be that mirror image. So then it would look like this, right? So same thing, if I draw the original, here's the y-axis now. So the mirror image of that, so now it would go in this direction. Congrats, you made it. You made it through the whole pretest. I hope this was helpful. So just a reminder, I left a link in the description. I have a whole course on all the prerequisite skills in detail, modules, lessons, homeworks, quizzes, warm-ups, stuff like that. So just as you would for a regular class. So as I said, I'll leave a link in the description onto my website, and I hope I'll see you soon.